All right, so we're diving into some pretty heavy stuff today, huh? Quasars. Listeners sent in some interesting material on those, and let me tell you, I thought I knew a thing or two about space, but this is next level.
Yeah, quasars. Definitely not messing around with those. What gets me right is how deceptively beautiful they are.
Right, like, oh, pretty light, sparkly space, but really,
It's like looking at, I don't know, like a beautifully crafted bomb or something.
yeah,
You know it's dangerous, but there's this weird allure.
exactly, and the science behind them, the sheer power.
Okay, so we hear supermassive black hole thrown around, right? But like, what does that even mean? These things make our sun look like a dust speck.
Uh,
We're talking billions of times its mass, just sucking everything in like a cosmic vacuum cleaner.
okay, and that's what creates the whole light show, right?
Exactly. So all this stuff gets pulled in stars, gas, whatever, and it starts spiraling towards the black hole. But it's not a smooth ride. There's so much friction, everything heats up to millions of degrees,
Mhm.
and that's what creates the quasar's light,
So it's like a cosmic car crash, but the wreckage is glowing brighter than anything in the universe.
pretty much. And that brings us to problem number one if we, hypothetically got too close. Radiation.
Yeah, the material mentioned that something about it being a bit more than a sunburn.
Oh yeah, just a tad. We're
Yeah.
talking gamma rays,
Mhm.
X-rays, the kind of stuff that just tears through everything. Our sun, it emits some radiation, sure, but it's nothing compared to this. Ozone layer, that's toast. DNA, scrambled. We'd be cooked from the inside out before we even knew what hit us.
Okay, so distance is key. Got it. But even then, there's the gravity thing, right? I mean, black holes, they have a reputation.
Right, and for good reason.
Sure.
Quasars, same deal, just amplified. Imagine for a second the force of gravity pulling on your feet being thousands of times stronger than the force on your head.
Ow, my spine.
That's what we're talking about. That kind of gravitational gradient would stretch Earth out like, I kid you not, like a piece of spaghetti.
Subgratification.
Well,
Catchy.
it's brutal. And if that wasn't bad enough, the material also mentions something about our atmosphere.
Oh, right. That was not good either.
Not good at all. So on top of everything else, quasars also have these insane cosmic winds. Not a gentle breeze, mind you. We're talking particles blasted out at ridiculous speeds. And that's what could strip away our atmosphere,
So, no air to breathe, no protection from space, game over.
basically. The Earth as we know it would just cease to exist.
Okay, so quasars are terrifying, got it. But that got me thinking, right? If they can do this to a planet, what about other stuff in space? Like, what happens to stars or gas clouds that get too close?
You're talking about a cosmic demolition derby, and astronomers are still trying to piece together all the rules. We do know quasars are messing with the universe around them in huge ways.
Makes you appreciate our little corner of space a bit more, doesn't it?
It does.
All right, that's about all the time we have for today's deep dive. But hey, next time you're looking up at the night sky, just remember, out there, somewhere, there's a quasar putting on a spectacular show. Just, be glad you're seeing it from a safe distance. Thanks for listening.